Hi, this is Jay Strachey with Drilling Contractor here at the IADC ART Spark Tank in Houston, Texas. Joining me today is Tab Manning with Pratt Hydraulics. Tab, thank you so much for joining us today.
Thank you for having me.
In your presentation today, you discussed the Tan Delta oil quality sensor and how in real time it detects oil changes and degradation. Can you tell us a little bit more about how this technology works?
Yeah, so basically the sensor is placed in the oil, and it's real-time monitoring of the oil degradation, and it's basically measuring energy loss of the oil. So every oil starts with 100% energy, and then as it degrades, the energy is lost, and it's measuring that basically angle of loss, the phase angle of loss of energy.
How did you test for the accuracy of this technology, and what were your findings?
There's a couple of things we do to determine accuracy of the sensor. One is we do lab correlation between what the readings are actually in an application and send those to a lab and compare the results. In addition, we know that the sensor will be accurate within one level up or one level down on the oil quality scale. And the oil quality scale, it's called the oil quality index, and it goes from -2 up to 21. There's a range where the oil is good, a range where the oil is bad, above that, and then a range where the oil is not necessarily bad, but there's some sort of error if it's below -2. It's a simple scale, basically letting you know oil's good, bad, take action, don't take action. The sensor is measuring the oil degradation. So as different factors, there's 13 to 16 different factors it's looking at. For example, viscosity, change in temperature, change in humidity, water, particulate, and many more factors that it's looking at. As the algorithms in the sensor see these changes and they correlate with each other, it's going to give an output that either the oil is good or bad. Green is good and red is bad. And also you can adjust the alarms per asset.
And then can you give us an example of the results you've seen with this technology in the drilling industry?
On a diesel engine, all the rigs have diesel engines. I believe it's 5 or 6 diesel engines per rig, depending on the size of the rig. We've saved 27,000 euro of downtime, which is oil changes and so forth, per engine. So if you take that over 5 or 6 engines per rig, that's significant savings. So when you're not having to shut down that engine, change out the oil, have the operator, maintenance person doing that type of work, that's where all the savings starts to add up.
Thank you so much for joining us today.
I thank you very much, and I appreciate the time, and y'all are doing a great job.
And thank you for joining us at dc.org.